Now, on a typical large-scale network, routers or any other routing-capable device will need to maintain a very large number of routing entries, and that is going to consume a large amount of device resources, random access memory, CPU resources, and even forwarding resources, lookup. In addition, the IP routing table size is going to be increasing, resulting in very low efficiency of routing into lookup. Therefore, we need to minimize the size of the routing tables on routers while at the same time ensuring IP reachability between routers and different network segments. If a network has scientific IP addressing and proper planning, we can achieve the goal by using different methods. One of the most commonly used methods, and that is also very highly effective, is the method of route summarization. Route summarization is also known as route aggregation. We talked about subnet division and variable length subnet masking, and we used those to resolve the problem of address space wastage in a previous chapter. But also, these cause a bring challenge. These cause a new challenge. These cause a new challenge to our network. They increase the routing entries in the IP routing table. Because, for example, we had a total of one address 192.168.0.0/16, and because of VLSM, variable length subnet masking, we decided to subdivide this network into several /24s. That is a great thing. But now we have to create a different route entry, either statically configured or dynamically generated, for each of these routes we have created. Instead of having one route entry in our router, we now have several different route entries. This is going to cost the router more time looking up which entry to be considered for the current packet. It's more CPU and more storage space. Random access memory, to store all this information. Route summarization can help minimize on these routing entries. In this example, we have router B connected to router A, and router A directly attached to all these several /24 networks, .1, .0, .2.0, .3.0, .4.0, .5.0, and .6.0. When you look at router B's routing table, it will have a way to reach .1.0, and it will say the next stop is that interface on router A. A way to reach .2.0, and the next stop interface is that interface on router A. .3.0, .4.0, .5.0, .6.0. To route traffic to directly connected network segments of router A, router B must have routes to these network segments. If a static route is manually configured for each network segment, the configuration workload will be heavy, and router B's IP routing table will have a large number of routing entries. This is the background of route summarization. But what exactly is route summarization? So in a similar case, where we have router A that will need to reach several network segments that are all directly attached to router B, instead of having a different route entry for each of these routes that are attached to router B, we could simply think of an original route from which all these route entries were generated, .1, .0, .2.0, and so on up to .10.0/24s could all have been generated from .0.0/16. And as you can see, we are setting up a static route that says to reach that aggregated network or summarized network with a /16 subnet mask. Send your packets to that next stop. This next stop is router B's interface right there. So on router A, we are configuring a static route to directly connected network segments 10.1.1.0/24, 10.1.2.0/24, up to 10.1.10.0/24 of router B. With the same next stop, therefore, these routes can be summarized into one route. It is an approach, route summarization is an approach of summarizing routes with the same prefix into one summary route to minimize the IP routing table size and to improve device resource usage, particularly CPU and memory. Route summarization uses classless interdomain routing notation to summarize network segments with the same prefix into a single one. The routes before being summarized will always be known as the specific routes, and the routes generated after summarization are known as summarized routes or just summary routes. Let us look at how this is calculated. So if we have different routes, like .1.0/24, 192.168.2.0/24, 192.168.3.0/24, what we want to do is to convert all these networks into their binary equivalents. So 192 in binary, 168 in binary. The changing octet is this one in binary and .0 in binary, which is the host part. Now, for us to summarize all these multiple continuous network segments into one summary route that just includes these network segments, we need to ensure that the mask length of the summary route is as long as possible. For example, we don't want to make it a /16 if it doesn't have to be a /16. In order to achieve this, just write down the routes and divide the entire writing, the entire block into two parts. One part that is completely similar within the given routes. This and this and this are all similar from the beginning up to there. From the beginning up to there. They are all the same from the beginning up to there. And just write that as the summarized network address. So as you can see, this is the summarized network address. So these are all going to be host bits in our case. How do we summarize this? We summarize this as 192.168.0.0 / what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22/22. So this is a network that includes that network and that network and that network. It's a summary network. Instead of having a route in our routing table to that network, to that network, and to that network, we can now have one route in our routing table to this network, and with that route, we can reach each of these specific networks. That, ladies and gentlemen, is route summarization. But just like every solution comes up with a problem, a side effect, we also have some problems caused by route summarization. Let us analyze this problem. First of all, on router B, we have directly attached networks. 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0.4.0.5.0 up to .10.0/24. And router A connects us to the internet. Does this throw any bells? Does this ring any bells? If we want to reach any other network, we can just configure a default route on router B to tell it that in case you want to reach any network with any subnet mask, just send your packets to our friend router A out there on that interface. That default route is going to help us to access the internet. That's great. But we also want router A to be able to access all these networks through a summarized route. So what we do, we write a static route on router A that says if you want to reach any network, we summarize these individual specific networks into a summarized network /16. I hope you are following. And give it the next hop of router A's interface right there. So now we assume that router A can reach all these networks through the summarized route, and router B can reach the internet through this default route. But let us think about this for a moment. So what happens if router B has a packet to send to 10.1.20.0 network /24? There is only one route on router B, which says if you want to speak to anyone, send your packet to that next hop on router A. Remember, Our specific routes here do not reach 20. And so this is not entirely there on router B. So it can't send it to a directly attached network because it's not there. It's going to forward it based on the default route. So it will send the packet to the next hop that the default route specifies. When this packet reaches router A has a default, a static route, summarized static route, that says to reach any of the networks that can be part of this network. And yes, 10.1.20.0 is actually part of this network because this is a /24. It is part of this. Router A is being told to send it this side. And so router A will get this packet and bounce it back. Router B will receive that packet from router A and say, oh dear, I was told to send any packet that is going anywhere to you. Router A will receive that packet and say, oh, I see this packet is part of this network. I can send it right back. What are we having now? It is a layer 3 loop. It's quite a big problem caused by route summarization. How do we solve this? First of all, we can create what we call a black hole route on router B. This black hole route matches the exact summarized route. It says, if you want to reach this aggregated network with that subnet mask, send a packet to the null 0 interface. Now, our routers normally have an outbound interface associated with all static routes and dynamic routes. The outbound interface can be a real physical interface or a logical interface. These logical interfaces can be VLAN if interfaces, we shall look at those. They can be null interfaces, we shall look at those. So, this null interface is a very, very special interface. They can also be tunnel interfaces. Again, we shall look at those. They can also be loopback interfaces. Again, we shall look at those. The null 0 is a special logical interface, a special case scenario. It has only one interface number, and that is 0. So we always call it null 0. Null 0 is a logical interface that is always up. It is always up. Its state is always up. It never goes down. When we use null 0 as the outbound interface in a route, the data that matches that route will always be discarded by the router. It's like dumping that data into a black hole. Therefore, any route whose outbound interface is null 0 is normally called a black hole route. So what have we just done? We have told router B that if you receive any packet to this summarized route, please forward it to the null 0 interface. Now listen to the logic. This static route has preference of 60. These directly attached routes have preference of 0 because they're directly attached. That means if any route comes from there, any packet comes from there, for a specific route that is actually attached, it will be directly forwarded because the preference is better. For the one that is not specifically attached, like 10.1.20.0/24, it is part of the summarized route, but it is not directly attached to router B. This route is going to match this black hole route, and so the packets that match this route are going to be sent to the null 0 interface. They are going to be discarded. That effectively prevents the routing loop that we have just talked about. But is there a way for us to ignore, to just do away with such scenarios of having packets to networks that are not directly attached to us as part of our summarized route? We can do that with more accurate route summarization. So let us get into routing summarization a bit more. We have router B that has networks 172.16.1.0/24.2.0/24 up to .31.0/24. Only here. We have router C, it has directly attached routes from 32.0/24, 33.0/24, all the way up to 63.0/24. Now look at this scenario. If we configure this general summarized route with a big /16, we have a problem. Because if we give it the next hop of router B, all these networks are also part of 172.16.0.0/16. They are all part. And so packets that are destined to the router C networks will also be sent there because that's the next hop we specified. We do not want this to happen. We want to simplify our work, but again, we don't want to cause confusion in the network. Is there a way to summarize these ones such that they only match, the summarized route only matches these ones, and another summarized route only matches these ones, without summarizing all these into one route? Yes, and that is if we do exact matching of the involved routes. I talked about this earlier. Just write all the specific routes in binary and identify all the matching bits that are the same for all the routes. When you look at this, all these are the same for all these routes. These are the ones that are going to give us the network part. So instead of writing IP route static 10.1.1.0/24, that next hop, 10.1.2.0/24, that next hop, 10.1.3.0/24, that next hop, we can now write one summarized route. But look at this. We have identified the network based on the matching entries only. That is 10.1.0, yes, .0. But instead of using this 0, we are going to use the minimum of these, the smallest, which is .1, meaning we have done away with even the .0 network. We don't want it. That effectively gives us a summary route that only includes the routes in question that we need to deal with. This, ladies and gentlemen, is accurate route summarization. With this kind of route summarization, we shall not even need the black hole route that solves the other issue of general summarization. I hope this has been informative for you. Thank you for viewing.